Today's lesson is over congruent triangles. We're going to first start by defining what a congruent triangle is. You may already know this, and if you do, that is great. Triangles with the same size and same shape are congruent triangles. This means that all corresponding parts, the angles and sides, are congruent. Let's talk about corresponding for a second. When we did our unit over transversal lines being cut by parallel lines, we had a set of angles called corresponding angles. Corresponding angles were in the same position. So when we're talking about corresponding parts of congruent triangles, we're talking about angles that are in the same position, sides that are in the same position. Okay, we're going to get to this more when we talk about congruency statements. What a congruency statement is, it is used for when triangles are congruent, that we can write a congruency statement. Okay, this is just lining up our corresponding parts that are congruent. Okay, so down here in our example, we have triangle ABC is congruent to triangle DEF. So what this means is that angle A, right here, is congruent to angle D. Okay, notice how in triangle ABC, angle A only has the one hash mark. In triangle DEF, angle D has the one hash mark. Okay, so the position of our letters also notes that these angles are congruent. Okay, so angle A is congruent to angle D. Angle B, okay, that's in the second position on triangle ABC. It is congruent to the second letter, the second position of triangle DEF. That's letter E. So let's take a look. Here's B. We have two hash marks. Here's E. We have two hash marks. Okay, for triangle ABC, angle C is congruent to angle F. Both of these have 3. Okay, so for your congruency statement to be valid, it must match all corresponding angles and sides. Okay, next up, CPCTC. What is it? Okay, CPCTC stands for corresponding parts of congruent triangles are congruent. So, if we know that two triangles are congruent, then we know that every pair of corresponding parts is also congruent. Okay, so down here we have a few examples. The directions tell us to list all congruent angles and sides given the congruency statements. Okay, I'm going to work example number 1 right here. So let's zoom in on that real quick. Whoops, sorry about that. Okay, number 1 says triangle JKL is congruent to triangle PQR. Okay, so using the premise and the rules that we talked about up here with our congruency statements, we know that the first position of both of these triangles are going to be congruent. So angle J is congruent to angle P. Those are in the first position. So I'm underlining those in black. Okay, the second one we use red for. Okay, so angle K is congruent to angle Q. And then the last one, we have angle L is congruent to angle R. Okay, so that takes care of all of our angles. We're going to do the same thing for the sides now. Okay, so how do we know what the sides are? Well, it's pretty much the same as the angles. Okay, if we take the first two letters this time, so we have JK, side JK. Okay, JK is congruent to the first two in triangle PQR, so that would be P and Q. JK is congruent to side PQ. Okay, then we do the second and third. So KL, okay, I'm just choosing the last two of the first. KL is congruent to the last two on the second. Okay, so the last two here are Q and R. Boom. Okay, then we choose the first and the last. That's the last side that we need. So JL is congruent to PR. Okay, that completes everything that we need for our congruency statements for the angles and the sides. Now, how do you write another valid congruency statement? Well, the easiest way to do it is to just reverse the order of the original one. So if I reverse the order here, I could say triangle JKL or triangle LKJ. So LKJ. So I reversed it. So instead of going JKL, I go backwards, LKJ. Congruency statement still has to be there. Do the same thing on this bad boy. Draw my triangle. Go in the reverse order, so I'm working from right to left, RQP. Okay, now our problem is complete. Come down here to number 3. Okay, for number 3, given triangle KPM is congruent to triangle AYC, complete each of the following statements. Now, the first thing that I'm going to do if I see a picture like this is I'm going to go ahead and make sure that I label which angles are congruent and which sides are congruent. Okay, so to do that, K, I'm going to give, since it's the first letter, I'm going to give one little hash mark. Okay, on the second one, we go to A, give him the same mark. Do the same thing for the second one. So the second position, we're going to give it 2. 1, 2. Same thing for Y, gets 2. And for C and M, we give it 3. Okay, so we know right away that K is congruent to A, angle P is congruent to angle Y, and angle M is congruent to angle C. Okay, so we'll come back to filling all this in later. Now we're going to do the sides. So KP, those are the first two. Right on the side, just give a little mark. Do the same thing for AY. And I go PM, that one's going to get 2. So we go from P to M, 1, 2. Y to C gets 2. And then our remaining side will get 3. Now the reason that we do this, is because when we're filling out our problem, it makes it much easier and quicker to fill in all the missing information if we have already pre-labeled this. So now we take a look at our sides. Here's KM. Remember, we put 3 marks for KM, so we're looking on the other triangle for the 3 marks. That's either, you could call it AC or CA. Okay, I like to go in alphabetical order, so I'm going to call it AC. Okay, now CY, what is that congruent to? Here's CY, has 2 hash marks. Oops. Okay, on the other one, 2 hash marks, it's right here, MP. Do the same thing for PK. So PK, okay, that has the 1 hash mark. Do the same thing over here. That's AY. Or you call it YA, doesn't matter. Now for our angle, okay, angle Y, right here, 2 hash marks, or 2 arc marks, okay, on this triangle. Angle P has the 2, angle K has 1, angle A has 1, so angle K is congruent to angle A. Next up, angle ACY. Now remember, if you see angle and then 3 letters, okay, you start at the first letter. So I'm going to start at angle A. The second letter is where I head to next. So I go from A to C, and from C I go to Y. Okay, so the angle that we're talking about here is ACY. So if I actually draw this out, okay, it's going to look just like this, and we're talking about this angle right here. Okay, this angle has 3 arc marks. So on this triangle, the 3 arc marks is right here. Now remember, these have to be in the correct order. So if we started at angle A, remember angle A has one arc mark. This triangle we're going to start with angle K. So we start K, we go to M, then we go and finish at P. Okay. Let me zoom this out real quick. Oops. So for part G, we need a congruency statement that matches triangle MPK. So MPK, so one easy way to do this, okay, M has 3 arc marks, 1, 2, 3. P has 2, K has 1. So we're going 3, 2, 1. Now on this triangle over here, we're going to do the same thing, 3, 2, 1. So we go C, to 2, which is Y, and then to 1, which is A, so CYA. We're going to do the same thing for H. So the triangle YAC is congruent to what? Here's YAC, so we went 2, 1, 3. On this one, we're going to start at P, that has 2, go to K, which has 1, and then M. So P, K, M. Okay, now I'm going to get into some examples with some numbers. So to start, I'm going to do number 4. Okay, read the whole problem. First thing it says, given triangle STW is congruent to triangle BFN, find each missing measure. So STW, S gets the 1, T gets 2, W gets 3. You can do the same thing for triangle BFN. B is 1, F is 2, N is 3. Okay, remember we do this just to label the congruent pieces. Okay, so ST, I'm going to give that 1. TW, I'm going to give 2. And then SW, I'll give 3. BF is 1. FN is 2. And then BN is 3. Okay, again, we do this because it makes things easier. So, this one says missing measure. So we're not looking for things that are congruent. We're trying to find the actual measure that's missing here. So for BN, okay, BN, we don't have a number for, but we know it has 3 marks, 1, 2, 3. So on this triangle over here, going to look for the side that has 3 marks. That has 1, 2, here's 3. Okay, so remember, by the CPCTC, that if 2 triangles are congruent, okay, we have that, then we know that every pair of corresponding parts is also congruent. So SW, that has the 3 marks, is congruent to BN. That means that these are the same measure. Okay, so BN is 9 centimeters. Now TW, here it is. TW does not have a number, but it has the 2 hash marks. Okay, so on the other triangle, looking for the 2 hash marks, it's right here. It's 14 centimeters. So again, by the CPCTC, okay, we know that FN is congruent to TW, so they're both 14 centimeters. Last one, we have BF. Has the 1 hash mark. Over here, ST has 1. So these are both 17 centimeters. Okay, I can do the same thing with angles. Let's take a look at angle W. Okay, angle W has 3 arc marks. Over here we have N with 3, that's 82 degrees. Pretty easy. Angle B, here it is, has 1. On this one, angle S has 1, it's 67. Okay, let's take a look at angle F. Angle F has 2. Angle T has 2. Now we've run into a problem here. Neither one of these has an angle measure, so what do? Okay, we have to go back to a topic that we have discussed previously called the triangle angle sum theorem. Okay, so in any triangle, all 3 angles have to equal 180 degrees when you add them together. So over here, since this is a triangle that we're trying to find S, so we're going to work with this triangle. We know that B is 67. So if I add B plus N plus F, they're going to equal 180 degrees. So there's 2 ways that you can do this. You can set up a long formula, like 180 equals 82 plus 67 plus some number that we don't know. Or you can add the 82 and 67 and just subtract it from 180. Okay, so 82 plus 67. Here, we're going to scratch this. I'm going to add them on top of each other. 82, 67. 7 plus 2 is 9. 6 plus 8 is 14. Okay, so those 2 equal 149. Now I have to subtract 149 from 180. Okay, so the 1's cancel out, and it makes 0. 8 minus 4 gives us 4, but look, okay, we have to take 1 away from this 8 and give it here to the 10. So this is a 1, 3, that's 31 degrees. Boom. All done. Alright. It's going to be the last problem that we do together. And we're going to take a look at number 6. And now the same theory behind 6 can be applied to number 7. So you can use similar steps. The only difference is number 7 deals with angles, number 6 is sides. So here we have triangle UVW is congruent to triangle TSR. UVW. Okay, so UV gets 1, VW gets 2. Remember, these are hash marks. And UW gets 3. Okay, TSR. TS gets 1. SR gets 2. TR gets 3. Okay, they want us to find 3 values, x, y, and z. Okay, we'll just go ahead and work in order that they're listed here. So x, got to find that first. Okay, so the side with x is UV. It has the 1 hash mark. Okay, so we're going to write that down. 12x minus 7 equals, we're saying equals because we know that it's congruent. Another word for congruent is equals to. So 12x minus 7 equals, here's the 1 hash mark, it's 53. Okay, we're going to solve for x. Got to get it by itself, so I'm going to add 7 to both sides. Remember, what you do to one side, you have to do to the other. Okay, so that gives us 12x equals 60. I want to get x by itself still. So we know that 12 is being multiplied to the x. So the opposite of multiplication is division. So I divide by 12 both sides. These cancel out, just makes 1. 60 divided by 12 is 5. So there's x. X equals 5. Now if you wanted to check your answer, what you would do is you would take this 5 and you'd plug it back in here next to the 12. So this would be 12 times 5 minus 7 okay, remember 12 times 5, okay, that was over here. 12 times 5 is 60 minus 7 equals 53. So this does work. Alright, let's move on to the next one. Got y, x done. Now we're going to move on to y. Okay, here's my y. It's got 2 hash marks next to it, so 5y minus 33 equals the 2 hash marks over here, 57. Going to get y by itself. We're going to go through the same thing that we did for the x. First thing, add 33 to both sides. Okay, so these cancel out. 57 plus 33 is 90. Divide by 5 on both sides. 5 divided by 5 is 1. Okay, then we get y equals $18. You check your answer, you do the same thing. You take the 18, plug it in here for this y, so 5 times 18 minus 33. Okay, so that's 90 minus 33. And of course, this does give us 57. So we're good. Okay, last one. Z. Okay, Z's down here with side UW. Has 3 hash marks. 3z plus 14 is equal to, here's our 3, the 3 hash marks, it's 50. Got to get x by or the z by itself. Okay, this time we have a plus, so the opposite of addition is subtraction. We're going to subtract 14 from both sides. 3z, these cancel out, is equal to 36. Divide by 3 on both sides. This makes 3 divided by 3 makes 1. The z is now equal to 12. Okay, you can check this one as well. 3 times 12 plus 14. 3 times 12 is 36. 36 plus 14, that does equal 50. All done. Oops. Sorry about that. I didn't even realize that wasn't on the screen. My apologies. If you have any questions, please feel free to leave comments below. Make sure you hit the subscribe button. Hit the bell for notifications whenever new posts are uploaded. Appreciate y'all. Best of luck in your class.